Hello, I'm Bill Henning. Thank you for your interest in GeoLearn and for this part one of a series on GNSS derived heights. And this first part will be about different kinds of heights and a little bit about gravity. We'll touch on some issues about gravity and how they apply to our heights we get with GNSS. So what we're going to do in this session is simply touch on these different kinds of heights. The geoid separations will be explained in more depth in the second part of this series. And we'll talk about some of the other things and how they relate to gravity, or if they don't relate to gravity. So let's take a look at an NGS data sheet. Now, if you notice, there are several heights on this NGS data sheet. First, we have an ellipsoid height, and let's do this in red. And it has a certain value. There's an NAVD88 vertical datum orthometric height. There's a geoid height. Well, what is that? That's part of a hybrid geoid model. It's actually a separation from the ellipse that we use. And if you notice, there's a couple different ones. This one is 03, and this one is 12A. So how different are they? Well, there's 6 centimeters difference in those. So you're thinking, well, I guess it's going to depend which one of those I use. I'm going to get a substantially different result. We'll talk about that. If you notice on this sheet, then there's also accuracies. There's a network accuracy at 95% confidence, and there's a local accuracy, median local accuracy. So all that is this a relationship to the datum, if you will, to simplify it. And this relationship is to other stations that were done in the same campaign, same adjustment. And that is at 95% confidence. You're looking at centimeters. So you can see some of the different heights on this NGS data sheet. Here's some metadata. The orthometric height was determined by GPS observations. Hey, that's good. That's what we want to learn about. And a high-resolution geoid model. Again, we'll talk about that in the second session. And it was using precise observations and processing techniques. Well, that's interesting. So let's go back here a second and we say, okay, I see that over here. This orthometric height was done with GPS observations. And if you notice, it's published to the nearest centimeter. If it had been differentially leveled, using specifications and standards for differential leveling, either first or second order, it would have had 3 decimal places. It would have been to the millimeter. So just by looking at that orthometric height, we can tell that it was probably GPS derived.